let me know if you have any questions. We'll go from there. But once again, when I'm looking at 16, like just from last section, I just want to start factoring everything. Don't do that, okay? Don't factor. First thing you do is check, do I have common denominators? The answer is yes. If the answer was no, we would factor the denominators. But we don't have to do any factoring as of yet. We can really just combine these to one fraction that has the common denominator of a squared minus 8a plus 16. Just remind yourself this is subtraction. Subtracting, you are subtracting both of those. So do something to just as just a reminder since it is a binomial. So we have 4a squared minus a squared. That's going to give us 3a squared. And we have negative 16, excuse me. What was this? Did I? Oh, no, I just did something else. Okay, crazy lady, I can't combine those. So I do want to write this in standard form. I'm going to write it as minus 8a minus 16. All right, that's better. I'm getting lazy here. Now, once they're combined, now I'm going to factor. So I say, can I factor the numerator? And I can. It factors to 3a plus 4, a minus 4. Can I factor the denominator? The answer is yes. That's just a minus 4, a minus 4. Can I do anything? Yeah, I can simplify that. And my final answer would just be 3a plus 4 over a minus 4, with the restriction that a cannot equal 4, or just 4 because it was both minus. Here we go. And that would be your final answer. So take a second right now. Is there any part of that specific problem or anything in general that we did yesterday that people have questions with before we start moving on? Beautiful. Okay, so once again, I'm skipping around, so I was doing these, and they're in a weird order. Some of them are harder than others, and I didn't feel like doing that. So I'm gonna do, I can't even read the front because it's like so messy. Because we only got up to what? 8 yesterday?
Yeah.
8, okay. Let me decide. Let's go with 9. So once again, I'm skipping around. I picked that one because that one had a common denominator. But as I skip around, some of them don't. Once again, you can see my paper. It's a big old mess. So you might want to do it on a separate sheet. So our main goal, we're adding. We need a common denominator, and as of right now, there is not one. So the first thing I'm going to do is, can I factor my denominators? And I can factor the first one, right? So that would factor to x plus 2, x minus 2. And the second one just stays the same. So now I need to make a common denominator because those are not the same. Okay. So basically, if I have a term, or in this case a binomial, in my denominator, it needs to be represented in my common denominator. So I have an x plus 2 here. I need an x plus 2 in my common denominator. I have an x minus 2. I need an x minus 2. I have an x plus 2 here, but there was already an x plus 2. You don't need to write it twice. You just kind of, that's represented, so you're good. And then once again, that was from there. So that would be my common denominator. So once again, I needed the x plus 2, because they both had it, so that's repped. I needed the x minus 2, so I had to add that over there, and that would be my common denominator. So once again, if they have it in common, you only need to write it once. So this is the same denominator, so the numerator stays the same. This denominator is not the same. It had the x plus 2, but it's missing the x minus 2. So what I have to do is I have to multiply my numerator by x minus 2. So I'm going to kind of do this so I don't need to keep rewriting it a million times. Once I see I'm multiplying a number by a binomial, I'm just going to distribute it in, and that will give me 4x minus 8. Now I can combine them. So I can only combine them once the denominator is common. So I'm just combining like terms. 2x plus 4x is 6x. I can't do anything with the 8. And I just say to myself, is there anything else I can do to simplify? This has a GCF, so let's check that. What is it, just 2? And then I'd be left with 3x minus 4. So I factored it, there's nothing else I can really do. So that's my answer, right? Nothing, always check it, because you just don't know. We do have restrictions, and x cannot equal -2 or +2. I'm just going off that factory form, but that would be your final answer. So sometimes I feel like you always want something to cancel. It's not always gonna happen. You do your thing, if it cancels, great. If it doesn't, you just kind of leave it. But that's number 9. So main goal, okay, I'm looking at the denominators. Basically, if it's there, it needs to be represented in the common denominator. So you just have to kind of go through and see what you got and go from there. Are there any questions on number 9? Okay, sorry, I'm gonna skip around a little bit.
Can I ask a question?
Oh, yeah, I'm sorry.
So like what would happen if like you saw that it doesn't have the common denominator, and if you just like multiply them together? Like what would happen?
What do you mean?
So like instead of like factoring it out, what if you just like multiply them together? Would that be like
Oh, then that would just be a big pain. Like if you multiplied x squared minus 4 times x plus 2?
Yeah.
Then you get a big, because then you'd have to do that, but then you'd have to, so then you'd have to multiply this times x plus 2, this time x squared minus 4, and then once you combine them, you'd have to factor the bottom anyways, and then it would just be a big pain to factor. So I don't recommend doing that. It's gonna actually make way more work. I know, like the logic makes sense. It's just the terms are gonna get all sorts of messy if you try to do that. Okay, so let's try to do another one that's kind of similar to that I'm gonna have you guys try one. This is number 10. And then he's doing it here instead of projecting it because I was gonna get annoyed. So very similar. We're seeing some denominators, they're not common. So the first thing I'm gonna do is say, okay, let's factor as much as we can. And in this case, I'm just focusing on the denominators. That would factor to n plus 5, n minus 5. I need a common denominator, so I need everything to be represented. So I need an n plus 5 in the denominator. You good? Now this is n plus 5 as well, but once again, we already have it. Why did I write n? Oh no, that is n. I thought it was the n's. That's already represented, so I don't need to write it twice. And if you had 2 of them, you'd have to write it twice, but just 1 in each, it's already repped. But we do need that n minus 5 there as well. So that's my common denominator, n plus 5, n minus 5. So then I ask myself, did I change the denominator? Because I have to change the numerator. And in the first term here, I did, right? I only had an n plus 5. So I ended up multiplying this by n minus 5. I have to do the same thing up here. So I tend to, at this point, just distribute it, and then that's going to become my numerator. That would give me 8n minus 40. Over here, this is my common denominator, so I don't do anything to the numerator. It stays. Just be careful as you are combining these, this is subtraction, so make sure you're subtracting both terms. And our main goal is to now just make it into one fraction. All right, so let's combine like terms. 8n minus 2n, give me a good old 6n. Negative 40 minus negative 15, that's negative 40 plus 15, that's negative 25. So, okay, I'm all combined, feeling better. I now have one fraction, which is what I wanted. And I just asked myself, is there anything I can do to the numerator? And the answer is no. So that's just my answer. There's no common denominator, there's nothing I can do to factor it. We would write our restrictions, which n cannot equal negative 5 or positive 5. just based off of those denominators. Sorry, I'm trying to find another one that's not like disgusting for you. Oh, man. Okay, okay, so very similar to that last one. I'm gonna have you guys try one like that, and then we're gonna kind of just see a few other things that might happen. Are there any questions right now with number 10 or with anything in general? Okay, so I'm gonna give you one similar to that. This is not on here. I'm actually kind of just like making up my own problem based off of one of these, but it's not exactly on the paper, so just do it on a separate sheet. We're gonna do 3x plus 5 over x squared minus 9 minus 1 over x plus 3. So I kind of took something but changed it, so it's not actually on there. So to the best of your ability, if you're saying, hey, can I just do the steps we just did? Because we're gonna do a few different things in a second with some other common denominators. I always like to give you a few minutes to at least practice a little bit. Give me another minute. A few seconds, we want to work them. All right, so we're gonna start. Looks like most people have finished up. So, not the same. Can we factor anything only in the denominator? So you don't really care about the numerator right now. So that would be x plus 3, x minus 3. Minus x plus 3. So what would the common denominator be? So we need the x plus 3. I'll write that here. We need the x minus 3. And then this x plus 3 is already represented, so you don't need to write it twice. So that's my common denominator. This stayed the same, so my numerator stays the same. This, I had the x plus 3, so I have to multiply by x minus 3. And I'll get that. That would just be what, x minus 3, because I'm multiplying by 1. And now my main goal is to subtract. Make sure you're subtracting both terms. You keep your common denominator. And then what does that give me? 2x it would be 5 minus negative 3, so 5 plus 3 is 8. Just do a quick check. If you can factor it, do so. We have a GCF there. That will give me 2 times x plus 4, which doesn't really help me, but that's how I'm going to write my answer. Nothing really cancels. And we would, in the end, say x cannot equal negative 3 or positive 3. And that would be your final. So as I'm looking at this as my answer, is there any part of this, any step that you get to the end and you're not agreeing, that people have questions? All right, let's look at one that has nothing in common in the denominator and see if we can find the common denominator. And then we'll just practice a few more. I'm just making this one up, so it's not on your worksheet. Some of the ones were a little aggressive on there. We'll just keep it basic because I really want to just focus on the denominator. So nothing too crazy going on in the numerators, but we see we want to add these two fractions. The denominators are not the same, so we need to find a common one. So I'm going to kind of rewrite it. Basically, you just need to remember if it's in the denominator, it needs to be represented in the common denominator. If I have an x plus 3 here, that means there's an x plus 3 in my common denominator. Okay? If I have an x minus 5 here, that means x minus 5 has to be represented in my common denominator. So my common denominators, you just multiply them together. You guys have done that a million times, right? If I said something like 2 7s plus 1/5, if you don't know a common denominator, you just multiply these together to get the new one. Same thing here. If you don't know it, you just take what you have and you multiply them together, and that's your new common denominator. So from there, you just need to change those numerators. The x plus 3 is represented. That means this first equation I'm multiplying by x minus 5, and I do the same thing in the numerator. That will give me 2x minus 10. Here, the x minus 5 is represented. I need to multiply by x plus 3, same thing in the numerator. That would give me 5x plus 15. And then I would write my common denominator. I would combine my numerators now with addition, just combining my terms. So what 2x plus 5x is 7x. Negative 10 plus 15 would give me 5. There's nothing else I can do to that, right? That's not factorable, nothing's going to cancel. I am going to write my restrictions because x cannot equal negative 3 or positive 5. So if nothing's in common, you just kind of multiply them together. The main goal is everything needs to be represented. So if you see it, it's in your common denominator. Any questions on that one? All right, let's do one more and then we'll take our little break. This one I am taking off of your thing. It's number 17. So wherever you're doing them, whatever works. And then after our break, there's one more thing I wanted to show you. But that should give you at least a spot you can do those other problems. All right, so it's going to take me a second to write this bad boy. All right, so I look and I say, all right, okay. I'm adding and subtracting. I need a common denominator and I don't have one at the current moment. So the first thing I need to do is factor my denominators. So this would come out to be what? 3. Oh, that has a GCF, so do that off to the side. So that would factor to 3 times y plus 3, y minus 1. All right. So little things, we always are on the lookout for the stuff we talked about. GCF pops up a lot. This one just has a GCF of 2. Okay. And then that has a GCF of 3. I'll give you a second. I'm just want to get it set up. All right, so we have the denominators. We need to find a common one. So I'm going to make 3 new fractions. I need to find a common denominator. So with the binomials, it's just like you make sure everything's represented. There are coefficients, there are numbers out front, so we do need to find the common denominator of that. So just think about it like a normal problem. If I have a 3, a 2, and a 3, what's the common denominator? Okay, you guys scared me there for a second. 6, right? That's just like finding a common denominator anytime. We've done that a million times now. So if you have numbers, you have to take them into account, and you need to find the common denominator for those. For our binomials, we just make sure everything's represented. So we definitely need a y plus 3. So I write it for all of them. I know it's kind of annoying. This is why these get a little bit long just to write. Because if you don't write it, sometimes you get a little unorganized. I need a y minus 1. Okay. Y plus 3 is already represented, so I don't need to rewrite it. It's already there. Y minus 1 is already represented, so I'm good. That's my common denominator. Okay, it's looking like a beauty. Now we need to see, do we need to change any numerators? So we have, the binomials are good, but we went from a 3 to a 6. So we need to multiply this entire thing by 2, right? So that would give me 4y plus 6. So now look here. I went from a 2 to a 6, so I'm going to have to multiply by 3. And then the y plus 3 is already represented, but the y minus 1 is not. So I also have to multiply by y minus 1. So what I was doing, as I was doing this on my worksheet before, I did 3 times 3, which was 9. And then I distributed that in. So that would give me 9y minus 9. So it's really just like, you just have to kind of sit there and do every step. But like the numbers aren't crazy. It's really just not losing things along the way. To get from 3 to 6, I multiply by 2. The y minus 1 was represented, but the y plus 3 is not. So it's really just making sure everything's represented along the way. And I'm just multiplying that by 1, so that would give me 2y plus 6. What a beaut. Our main reason for doing that is now we can make one fraction with all those denominators there. And I'm going to now combine my numerators. Just be careful, that's addition, which is fine, but this is subtraction, so just make sure it goes with both. I'm going to go straight across. 4y plus 9y is 13y. Minus 2y is 11y. And then what do we, this is a plus right here. Sorry, it's a messy plus, so it's confusing. 6 plus negative 9 is negative 3. Minus 6 is negative 9. I can't do anything with that. That's my final answer, with my restrictions that y cannot equal negative 3 or positive 1. So I'm going to leave that up for a second. That one, like, once again, there's a lot of steps you have to write down just to stay organized. The steps, if you look at them individually, aren't bad. We're not doing anything too crazy. It's just making sure, can you get that common denominator? That's the big one. Change your numerators, and then can you combine everything and go from there. All right, I'm going to do a little pause here. I'll go from there. So I'm going to do one more from here, and then there's one more other one. If you get to it, great. If not, it's not a big deal. But this one, I know this like little part pops up a few times, and so I just wanted to make sure we saw it together. This is number 19 on this worksheet. If you're on there, great. If not, you can do it wherever. All right, so give me a second to write it. Okay, so I look at this and I say, all right, definitely not a common denominator, so I'm going to need to find one. So the first thing I'm going to do is factor my denominators. Okay, the first denominator is difference of 2 squares, so I'm going to throw that bad boy in. The second denominator, so this happens a lot where it kind of flips it and it makes it annoying. So what you wanna do is put it in standard form. That would be negative x squared plus 9. You're going to take out the GCF because we never want our first term to be negative. So that would be negative 1 x squared minus 9. And then you can factor it. So that happens a lot. I don't know why, just one of those things that always pops up, kind of flips the order on you. So I always do that as my first step. So I would write that as negative 1 and then x plus 3, x minus 3, now that I can factor it. And then the last one just stays, you can't do anything, right? So now I'm gonna write, there's a lot of writing in these problems. And just kind of figure out, make sure everything's represented in the common denominator. So I'm gonna need x plus 3. I'm gonna need x minus 3. Hold on, I'm just gonna write all of those so I don't have to rewrite it. Okay, so that's represented, that's represented. I need a negative 1 in front, so that goes with all of my denominators. So it has to be represented. X plus 3 is good, x minus 3 is good, and then x plus 3 is good. Okay, so we got everything that we needed. So my common denominator is negative 1, x plus 3, x minus 3. Okay, so when I look at this, these are good, but that negative 1 is there. So this has to get multiplied by negative 1. I would get negative 3x plus 5. This is the same. That denominator is the same as the common denominator, so that numerator stays the same. This one we only have x plus 3, so I need to multiply it here by negative 1 times x minus 3. And that would give me negative x plus 3. So just little things that become with signs. So I'm gonna give you a second. I'm gonna erase over here in case you're catching up. Sometimes I get excited and go a little too fast. All right, are there any questions at the current moment before I move on to the next steps? So our main goal is always, now we can actually combine them. Just make sure I turn that on. So we have the common denominator. I'm going to just combine my numerators. So let's do the x's first. I have negative 3x plus negative x would give me negative 4x minus negative x. That'll give me negative 3x, right? Because when I subtract that negative, it turns into a plus. Okay, and then we have 5 plus 7 is 12, minus 3 is 9. Okay, so that wasn't that bad, just to actually combine them. Can I do anything else? Yeah, I noticed that the numerator has a GCF. We said we always want the first term to be positive, so I'm going to take out a negative GCF. I'm going to make it negative 3, and that would give me x minus 3. All right, almost done. And then what else can I do? Well, the x minus 3 is a common factor. And see how you have a negative over a negative? That would turn to a positive, or just kind of think of it as a common factor that would cancel out. So my final answer would be 3 over, you don't really need to write the 1, x plus 3. What a beauty. X cannot equal negative 3 or positive 3. I'm just going back and looking at the denominator. And then you do that. So these are, I agree, kind of annoying to do. Just there's a lot of, you'd have to do a lot of setup to finally get to the end. But just do your best and try not to lose signs. That's the big thing. Or just like little things. All right. So I'm going to attempt to do one more. Let's see if I make it. If not, it's not a big deal. I just wanted to show you one where you have to do a little bit more distributing. I don't know if it pops up, but I would rather have you see it than not see it. So this one is not in that packet. It's just kind of a random extra question. Which one was I gonna do? Okay. So we always start the same way. Is there a common denominator? No. Oh, I don't know why I awkwardly put parentheses just around that one, sorry. So I'm gonna factor, the first one's all set. The second one, I actually have to factor it. So that would be what, x minus 2, x minus 1. Common denominator, everything needs to be represented, so I definitely need an x minus 2 from there. It's already represented there, so I don't need to write it again, and I also need an x minus 1. Okay, so that wasn't that bad. I just wanted to show you, it's a step you know how to do, but it's one of those things if you haven't seen in a while, I'll remind you. This has x minus 2. So we have to multiply by x minus 1, same thing with the numerator. And I just wanted to see, you have 2 binomials here, you would have to distribute those. You can do it. That would give me x squared. And then I would get minus 1x plus 3x. So that would give me plus 2x minus 3. This one is already all set. Sorry, I know I'm in the way. I'm trying to write and slash beat the clock here. So the one step I did want to show you is just, if you have 2 binomials, I feel like sometimes we don't put parentheses. We're like, what do I do? Just put parentheses and distribute it. Combine like terms, we are subtracting. That gives me x squared. It's 2 minus 6, which would give me minus 4x. Negative 3 minus negative 7 would give me positive 4. I can factor that, right? X minus 2, x minus 2. We have a common factor. Sorry, I know I'm rushing. And my final answer is x minus 2 over x minus 1, with the restriction that x cannot equal 2. My arm hurts. But that should at least set you up to be able to try everything. Remember, I'm after school